I thought we only had functions. That was a comment you made, right?
Mm-hmm.
So you will just come to accept that math should be spelled F-U-N. There we go.
How about not? No.
Okay. Most basic equation of life. There you go. That's a good quote.
Are you sure that's been mental?
Okay, so
Well, yeah, that's a fantastic one. Why is it a theory?
you all know how to solve this definite integral, correct?
Yes.
Already?
Yes, before we
What?
move on, and I forget my question. Why is it the fundamental theorem? Why not?
Because this defines the relationship between derivatives and antiderivatives.
Should be law then?
Yeah, because it can be proved over and over, and has been
Oh,
proved for centuries.
here's the thing. No. You have a history lesson in math.
Yeah, of course.
Okay. So,
All captains, just to be.
all right. So, in order for something to be a law, it never fails, right? Like gravity. You jump out of an airplane, you're going to fall, right? Because Superman doesn't actually exist. Okay, so that's a law. Okay, something like evolution, nobody was there.
Yeah.
We can't prove it's a law, so it has to be a theory supported by evidence, right? We look. Some people don't believe that. Some people do. We look at the evidence. Some people come to different conclusions, right? Okay. Mathematics is built upon a lot of facts, but the theoretical base of mathematics, right, is built on the arithmetic side of math. You could call a law, right? It's just not going to change. It's defined, but the theoretical side of math is based right now on 3 axioms and their basic assumptions about how things operate. Okay, all the theory of mathematics is built on those 3 basic assumptions and logic.
What are those three
Okay,
basic assumptions?
those 3 basic assumptions have to be true for that to be a law, right? We don't know that they will never fail.
Ah,
Okay, so we call that theory. Mathematical theory, not mathematical law, and we have theorems within that theory. Okay.
all right. Yeah.
So my senior research project was about that. So about 150 years ago. So mathematics, we're on a rabbit trail here. Mathematics has to, so within about 150 years ago, that's how old math is as you know it. The theoretical basis of math is only about 150 years old. Okay, the concepts and some of the calculations come from way back, right? But the theoretical basis of mathematics before what we have now had 3 axioms. Those axioms worked and worked and worked, but at some point there was something that gave a logical inconsistency. Okay, so you have something that can provide a false and a truth from the same statement. Okay, that showed that those axioms, that theory was not true. Okay, so that fell apart. They had to build the current system based on 3 different axioms. Right. So mathematics, while every time we do something, every time a new theorem is proven correct, it increases the probability that everything is correct, but we will never know. There's a guy named Kurt Gödel that actually mathematically proved that you can't prove that mathematics is a law, basically. Consistent is what the word is. Yeah, so we'll never know if this is consistent or not until it's proven inconsistent. Because we can't prove that it's consistent.
Which law?
So there's your basic history lesson.
All right.
Back to fun, the mental theory.
Okay. Thank you.
So, yeah. A lot less stable footing of mathematics than you think. We've always said, well, mathematics is law and truth, right? Well,
No.
not necessarily at the theoretical level. So, there you go. Okay. You know how to solve that problem, right?
Yes.
If we define f of x as x squared, okay, you would, okay, evaluated from, which is,
4/3. 63/3 minus a third, so you, that is
right?
23.
So,
Just 27 minus 3, so it's
let me make that easier to see.
no, solid.
21 and 1/3.
Oh, because it's 63 over 3, it's 64 over 3. Minus a third, which is 63.
21.
You got me there, you friend.
Right, we can make that statement correct.
Right.
Do you agree with it?
Yeah.
So, how else can I write that using the antiderivative? Whoa.
F
How did you
at
do
4
that?
I don't know.
minus big F at 4 minus big F at 1.
Yeah,
But how would we add that thing?
correct. You just basically shown the relationship between derivatives and antiderivatives with the fundamental theorem of calculus. That's just an example that shows it.
So instead of writing out
Okay.
4/3.
All it does is allows us to, the fundamental theorem of calculus allows us to make these calculations and trust that they are true and correct. As far as the three axioms are true and correct. Okay, so let me write out the fundamental theorem of calculus and we'll compare this. Okay, if we assume f of x is what?
Continuous and differentiable?
Continuous. Okay.
So that's my boss wants you to talk about.
On some interval.
What happens when we assume it?
Oh, yeah.
There's always, remember, there's always an assumption, an if, in a theorem, right? If f of x is the antiderivative of f of x, big F is the antiderivative of little f.
Oh, yeah, this
On the interval. Then there you go. There's all sorts of neat, pretty stuff in your book about the proof. The proof is actually in there. It is 1 3/4 pages long. Have fun with that.
ridiculous.
The proof uses remember how I told you about the size of the rectangles getting smaller and smaller?
Yes.
The limit definition of an integral, then that's how the proof is used. The proof uses that.
Really?
Yeah, I know. Okay, so do you see the parallels between the two?
Yes.
Okay. All right. So that's how your book would write this. Okay.
How does AP want us to write it?
No. Two.
Oh, I love these models.
Okay. In our book version, what was the antiderivative?
Big FX.
Big F.
Yeah.
Okay.
F prime X is it now.
Little F is it?
Big F prime X, right? Big.
Which one's the antiderivative?
Big F.
Big F is still the antiderivative. They just state it differently. See that? This is,
Big F prime is equal to f of x.
that is saying,
If you derive big F, you get F.
yeah,
So this is a situation where the antiderivative in one position would mean something.
so what we're saying here, okay, if I integrate f of x, I can substitute. This is the easiest way for me to understand it. Right? Same thing. Correct? What's the integral of a derivative?
This equation.
So what's the answer to this question?
D.
D. Okay. So you see the subtle difference between the two presentations. It's the same concept. They don't change anything. They just change the presentation of it. But the easiest way I found to work through these is to substitute if it's a theory-based problem. Okay. Everything else in this section is calculating antiderivatives and integrals. Okay, so the last one that I would point out is, do you remember that antiderivative of 1 over x?
Wow.
Natural log x.
Not quite.
Plus c. Oh wait, no. At the absolute value, dang it.
Yeah, why is it absolute value?
Because that's all I could
I don't
do.
know that answer.
Natural log does not have negatives in its domain. What's really neat is it still works out. Okay. There's a lot of stuff behind that, but yeah. So remember,
Has to do with your little yellow book about calc.
So that's one of those things where like if we don't write an absolute value, we don't get
You got a little yellow
yeah,
book
if you miss that absolute value there, you don't get credit.
I'm just gonna put very straight parentheses.
Of course, multiple choice. You might get the right answer anyways, but. Any questions? All right. Did that explain it better than last year?
Yeah. Dude, I don't even know what the homework is. Is it just always like trying to give you like a grid?
Yeah, it's a lot of calculations, honestly, yeah, so.
Or they give you table and it's all?
Yeah, it's like $7 to
You get wrecked.
No, we were a team.
Oh.
We played the Sands.
Pardon?
Why?
Yeah.
I actually just go home after school this week.
Not today.
Didn't you go home after school last week?
Not directly after school.
Okay. Now you're being specific with your language.
Just like we have to on the test.